To describe a voltage source in Symbulator, first we provide its name. It has to start with the letter E and it has to be unique. It can be between 1 and 8 characters. Then we provide the name of the positive node, then the name of the negative node, and then the value. Since Symbulator is a symbolic simulator, this value can be symbolic, like in this case, where it is equal to a constant V. To run a direct current simulation in Symbulator, we use the program called DC. And the way to invoke this program is by typing s/DC and then passing as argument a string, including the description of the circuit. Now, instead of the string, we can also pass a variable that contains the string description of the circuit. To simulate this circuit in direct current using Symbulator, first we have to name the nodes and elements. We name the nodes 1, 2, 3, and 0, 0 being the ground node. All voltages in the other nodes are going to be given in terms of the difference in voltage between them and the ground node. And then we name the elements, which here we name E for the source, and R1, R2, R3, and R4 for the resistors. Once we have named the nodes and the elements, we can proceed to describe the circuit. We have a source, E, with a positive node 1 and a negative node 0, and a value of V. We have a resistor, R1, connected between 1 and 2 with a value of R1. And so on, we describe the other 3 resistors. We copy this description from the text editor, for example, and we're going to store it into a string. We can use the custom menu. Between the quotation marks, we paste the description of the circuit. When we press enter, it is stored in this variable CIR. Then we ask Symbulator to run a DC simulation for this circuit. Once the simulation is completed, we read done. And we can see that in the main folder, besides the circuit description, we also have a series of answers, including the currents in all the elements, the power consumed in all the elements, the equivalent resistance of the circuit as seen from the source, the voltage in all nodes, and the voltage drop in all elements. Let's say, for example, we want to know the voltage in node 0. Of course, it is 0 volts. In node 1, we ask for V1. In node 2, we ask for V2, and V3 for the voltage in node 3. For the currents in the resistors, we just ask IR1 for resistor 1 and so on. For the voltage drop in the resistors, we ask VR1 and so on. For the power consumed in the resistor, we ask PR1 and or the name of the resistor R2 through R4. And then for the source, if we want to know the voltage in the source, we ask VE, the current IE, and the power PE. This is because of the name we gave to that source. And if we want to know the equivalent resistance that that source is seeing, we ask for RE. So let's learn a little bit more about these answers and the names given to their variables. There is a logic to the names in which these answers are stored. For a DC simulation, we will get the voltage in all nodes, and that's going to be stored in a variable called V and the name of the node. For example, if the node is called 2, voltage in that node is going to be called V2. We also get a series of answers for each resistor. We get the current through the resistor, stored in a variable called I and the name of the resistor. For example, for a resistor called Rx, it would be IRX. It's given in amperes, and it's defined as running from the first node to the second node in that resistor's description. We also get the voltage drop in the resistor, stored in a variable called V and the name of the resistor. It's given in volts, and it's defined as the voltage of the first node minus the voltage of the second node, based on the description of that resistor. Then we also have the power consumed in that resistor, which is stored in the variable P and the name of the resistor, given in watts. And since it's a consumed value, positive values mean this is power consumed. Now, for voltage sources, we get the same three answers. That is to say, we get the current through the source, stored in I and the name of the source, given in amperes, and running from the first node to the second node, meaning this is the current running from the positive node to the negative node. We also get the power consumed by the source, stored in a variable P and the name of the source. It's given in watts, and if you want to know instead the power delivered, what you do is that you just change the sign of whatever value you get. The voltage drop in the source is stored in a variable V and the name of the source. But here's the thing, for sources you get this additional answer, which is the equivalent resistance of the rest of the circuit as seen by that source, and that is stored in a variable R and the name of the source. It is given in ohms. Now, Symbulator is a symbolic simulator, and so far we have been using symbolic values to show this. But Symbulator can just as well do simulations using numeric values. This example, which I want you to solve on your own, is given in terms of numeric values. So why don't you go ahead and try solving this circuit, finding all the voltage in all the nodes and all the currents, voltage drops, and powers consumed in all the elements, as well as the equivalent resistance as seen from the source. I suggest you pause the video now, and when you're done, then you can compare it to the solution I'm going to show you. Alright, so I assume if you're listening now, it's because you have already solved the circuit or don't care to do it on your own, because now I'm going to show you how to solve it. So first thing we do is that we name the nodes. The ground is given the name 0. You should always have a node 0 when you're doing a DC simulation or an AC or transient or frequency domain simulation. You should have a ground, and it should be called 0. This we will call node 1, 2, 3, and 4, and 5. Now let's name the elements. We have here our resistor 1, R2, R3, R4, R5, R6, and R7. And the voltage source we will call E. Having named the nodes and the elements, now we proceed to describe the circuit by describing each element one by one. So we have a source that we will call E, connected with the positive node in node 1, the negative node in node 0, and it has a value of 240 volts. So we describe it as E, 1, 0, 240. And the resistors, you should already know how to describe. R1, 1, 2 means a resistor called R1 connected between 1 and 2, and with value of 3. So you say 3. And then R2, 2, 3, 4, and so on and so forth. So we type this description of the circuit in the text editor of the calculator, and then we copy that description, we bring it to the command bar, and we're going to store it in a string into a variable called whatever we want. In this case I call it SIR, and then I ask Symbulator to run a DC simulation using SIR as its input. I'm increasing the speed of the calculator emulator just to get the answers faster. And then after the simulation is completed, I can ask for the voltage in all the nodes, which is basically V and the name of the node. I can also ask for the voltage drop in the elements. And the current through the resistors here. And the power consumed by the resistors. And I can ask for information about the source, such as the current through the source, the voltage drop in the source, the power consumed by the source, and the equivalent resistance of the circuit as seen by the source. Easy peasy.